Alright, so how does panel data look like? This is how your panel data is going to look like. So over here, you're going to have countries. For example, these are Pakistan. Don't write Pakistan over here. You can also decode it in Stata, but the easier way for you is to have such kind of a country. For example, Pakistan, then name it 1, 2, 3. So this is Pakistan, Pakistan, Pakistan. You name it 1, 1, 1. But do remember that you have kept 1 for Pakistan, 2 for India, and so on. Okay. So for Pakistan, then you are taking 3 years. Pakistan year 2000, you have the data of Y, that is GDP per capita. This is X1 variable. You can call it population. Then these may be digital skills. This may be institutions. Okay. So this is the shape of the data that you are going to use for the panel data. You can use the panel data in 2 shapes in Stata. One is the longitudinal data and the other one is the latitudinal data. It is a little bit difficult to handle the latitudinal data. So mostly researchers use the longitudinal data. Or you can say it is, I find it easier to use longitudinal data. All right. So basically, there are many benefits of panel data. And one of the benefit of panel data is you can see the impacts on a regional basis. Okay. So for example, if you are using a panel data, you can lump up such countries which have same institutional structures. Right? You can say Pakistan, India, Bangladesh, they have similar kind of institutions, so you can lump them and you can have a more better results for a region. So this is one of the benefit of panel data. Okay. So today I'm just going to be telling you about 2 techniques which are very basic technique. One is the fixed effect and random effect. What is the econometrics behind fixed effect, random effects? You have already covered in economics. I'm just going to tell you that how you can do this in Stata. All right, so this is how your Stata screen should look like. When you're going to open the Stata, this is a Stata screen. This is here where you're going to write the commands. Okay. Over here, all of those commands are going to be shown up, which you have already given to Stata. Okay. Here are the list of the variables that you're going to import in this data. Okay. And over here, this is the data editor. Okay, you can also save all of your commands so then tomorrow you can just do all of these commands with 1 or 2 clicks and there you store it in this do file. For now on, look at this data editor. It looks very similar to an Excel sheet, right? So you're going to have all your data imported over here. And once your data is imported into this Excel kind of sheet in Stata, then you can put the commands over here and you can do your estimation. All right. So first of all, we are going to have some data over here. Okay, so I have imported some data set over here. And over here, you can see that this is basically a data set in which you have different country names. Okay, and again, these country names also have been encoded by a variable called ID over here. So I have basically encoded here. And you can encode it if you want to, or you can just put 1, 2, 3 and then import it. For you, just do that. Put 1, 1, 1 where is Pakistan and you can have it. Basically in Stata, I have done this, that I have labeled it in Stata that Armenia take it as 1. Bangladesh take it as 2. Okay. So you can see the cursor, right? Okay. So similarly, if it is Bangladesh, take it as 2. And so on. And this is a huge data set that I have over here. Basically, it has then years in it. So for each of this variable, so if it's Armenia, Bangladesh and so on, the data is ranging from 2007 to 2020. Again, for Bangladesh, it is going to be for the same years, 2007 to 2020. So this is kind of a data set which is called as balanced panel data. I'm using this data set. Okay. So the first step that you are going to do is, let me open the slide so that you can also see what are the commands that I'm giving. First of all, you need to tell your Stata that take my data in the shape of panel data. Okay. Don't take it in the shape of cross-sectional data. Don't take it in the shape of time series, but accept this data as a panel data. So the command would be xt set id. ID is that column in which you have put countries 1, 1, 1, 2, 2, 2, 3. Okay. And the other is xt set ID and years. Years column has all the years in it. And then you're going to say enter. So the Stata has taken this variable as a panel data. And it says that the ID is strongly balanced panel data. It has a time value from 2007 to 2020. Okay. Now you want to make some graphs out of it. Okay. You want to see how your data looks like. So the command for that is xt line and then the variables on which you want to make the graph. So these are the some of the variables that I have. Okay, so if I want to see how the trends of human capital has been varying from 2007 to 2020. I'm going to use this command, xt line, and then that variable. So simply you go to that variable, this kind of a sign appears, right? And from this sign, you just click it. So automatically this variable name is going to come over. If you use this process, you're going to, one, save your time. Secondly, you're going to be safe from making any error in the spelling. All right, so you press enter. It's going to take some seconds to operate. So we're going to wait for it. So whenever this is in black color, it means that that command has been generated. If this comes in red color, it means there is some problem and this command has not been generated. So you need to be also vigilant about the color of the command. If this is red, it means there is some problem, the command has not been generated. Okay, so here you can see this is the graph. So this is the data of human capital and you see in just one click, how many graphs did you get? Okay, so Jamal, you can add these graphs into your introduction part. Okay, so human capital has not much varied in Armenia, Bangladesh, Malaysia. There are very little changes, Cambodia and so on. India, Indonesia and China and South Korea. These are the 4 countries in which we see that human capital has increased. And if you see, it is also logical to believe that since India, China, Indonesia, these 3 countries also has seen a tremendous growth in the last 2 decades. All right. So this is basically a picture of showing you graph of different countries in different small panels, you can say. What if you want to see all of these countries in one graph? Then you can use another command, which is xt line investment. Okay, it is not for human capital, it was for investment. Overlay. Enter. All of these commands are also noted in this slides. Okay. So this is the graph. And over here you can see that this is for China, followed by this red line, which is of India. Then the blue line is for Armenia, whatsoever. However, you can see that all of this now data has been lumped into one graph. So you can in this way create multiple graphs in just 1 or 2 clicks in Stata. So this is the benefit of the Stata. If you're going to do it in Excel, it is going to take a much longer time, right? You need to have summaries out of data and so on. But Stata is just going to give you in seconds. All right. So here you have learned how to make a graph. The next thing is to run fixed effect model. So the econo behind what is fixed effect, benefits and all that you have already discussed in econo class. Some of this is also given over here in this slide, so you can look into it. I'm just going to give you the command to do fixed effect over there. Okay, so this is the command. So the command is xtreg. You're going to first write your dependent variable. Let your dependent variable be human capital, and then your independent variables. So your independent variables can be population, labor force. You don't take labor force and population in one model. Okay, so then it could be inflation, it could be trade, it could be institutions, okay, investment. So ignore that. Okay, so these are those variables that can affect human capital. Population, inflation, trade, institutions, and investment, they are affecting the human capital. So if you write the functional form, how would you write it? HC is a function of population and all that with comma. If you are going to open that and write it in the mathematical form, you're going to write as human capital is equal to beta naught plus beta 1 in brackets population plus beta 2 brackets inflation so on plus error term. Okay, so this is basically the application of that mathematical model. To apply fixed effect, you are going to write comma FE. FE stands for fixed effect. And then you're going to press the enter. These are the results of your fixed effect. Okay, fixed effect model. Okay, so this is your R square, and the value of R square, overall R square is 0.26. Is it a good R square? No, it is not a good R square. Because your R square ideally should be above 0.75. What does your R square mean? It captures the variations in a model. It's very simpler words. All right. And what is this F stat? It shows that how good is your model. So it is basically the fitness of the model. It is significant, however. This shows that 195 observation has been taken into consideration for this model. It has 15 groups or 15 countries into it. And this is our model. Okay. So it means that population has a positive impact on human capital and it is insignificant. So basically this is the p-values, and I have already taught you that how you are going to tell about the significance from p-values. You're going to multiply this with 100 and then you're going to decide it whether it is at 1%, 5% or 10%. This is insignificant. Inflation is insignificant. Trade is significant. Institutions are significant. Beta naught, this constant is basically the beta naught. Okay, that is significant. And your investment is significant. So 3 are significant and 3 are insignificant. An ideal model should be in such that if you have, for example, 5 variables, try to make it in such a way that 4 are significant and 1 is insignificant. Okay. Yes, there must be, some problem in the data. You need to try different proxies of investment and so on. Because obviously your mind does not accept this, that investment will have, no impact on, an insignificant impact rather on, human capital. So you need to try other variations to make a better model out of it. Okay, so from this significance, from this signs, you can interpret this model. One more thing. You can also have this model made for you in Word automatically. So the command for it is outreg to using, for example, I keep the name ariba.doc. Okay, so this is the command, and you will see that automatically Stata generates this table for you in Word. See, this is basically an extension to what I have already done. So let me put some other name. Outreg to using Jamal.doc. Okay. Now look at it. So it has automatically created a table. Okay. So you don't need to write all the table now. Stata is doing all for you. Okay. So here this is the coefficient. In brackets are the standard errors. And these stars shows the significance. 3 stars mean it is significant at 1%. Okay. 2 stars shows it is significant at 5%. Okay. And if it is 1 star, which is not in this case, then it shows that it is at 10% level. Okay. So if you can use this command to do it, very good. If you cannot use it, you can make a similar table by hand as well. Just look at those values and make a table out of it. So you have already done and learned that how we can do fixed effect models on panel data. The next command is to do random effect. Same would be the command for random effect. All you need to do is you're going to write comma RE. RE stands for random effect. You're going to enter this, and this is going to be the results of random effect. All right. So over here, this is a predictive of the fact that this has been the random effect model. Over here, you can also see that it has been labeled by Stata as well, that this is the estimations for random effect GLS regressions. What about this R square? It is even lower than before, right? But the overall model of overall fitness of model can be seen from here. It is same observations, same number of groups. What about the significance? 1, 2, 3, 4, 5. Now 5 variables are significant and 1 is insignificant. Okay. So, but it doesn't mean that you should use random effect and you should ignore fixed effect. What is the thing that is going to tell us is the Hausman test. So now let's learn how to do the Hausman test. Let me open the slides for you and make you see some other things as well. Okay, so this is basically an output of fixed effect. It is the similar output that you have seen. And in this slide, they have taught you everything that has been labeled over it. What does this mean? What does this mean? What is this and that? Okay, so this is a very detailed slide. Okay, so then this is the random effect. And again, they have explained random effect in very detail. That what does each of this sign means over it. You might have such kind of a question in your exam as well, that I can give you an output and I can ask you to label it or interpret it, that tell me either this variable is significant or not. So do take it seriously. Okay, so how to decide between fixed or random effect? Simply, these are the commands that you're going to follow. The process is, first of all, you're going to do this. The fixed effect model, you're going to run it. Then you're going to ask the Stata to store these results in its memory. The command would be estimates, store, keep it a name. For example, you can keep it a name fixed. Then you're going to run the random effects, RE. Then you're going to ask Stata to store this in its memory, estimates, store, random. Okay. Now you are going to ask this data to use the estimates that it has stored in its memory to compare the results of both and then tell us that which model we should follow. So for that, we are going to run the Hausman test. So Hausman, fixed, and random. Okay, so this is the output. You are going to see from this probability. If this is significant, then it means that you should apply your fixed effect. So basically what you need to do is you need to report the results of fixed effect. But in your paper, what you need to do is, when you're going to give me the paper, you're going to give me the data, one. Secondly, you're going to report all the fixed effect and random effect in the appendix. Okay. But in the main paper, just report the result on which the Hausman test is saying. So imagine if it was not significant at 5% level, then you're going to apply the random effect. Since it is significant, hence we can say that you can apply the fixed effect. Clear? So can you people do all this in your paper? Easy?